All right, so let's go through with continue with limits and continuity and the properties of limits. So given the limit as x approaches a of f of x equals to L and the limit as x approaches a of g of x equals to m, we can find each of the following limits in terms of L and m. So this becomes the limit as x approaches a of f of x plus the limit as x approaches a of g of x. And so this is just then L plus m. Number 2, we have the limit as x approaches a of f of x minus the limit as x approaches a of g of x. And so this is going to be L minus m. Number 3, we have the limit as x approaches a of f of x divided by the limit as x approaches a of g of x. And provided that m is not equal to 0, this is L over m. So we have the limit as x approaches a of f of x times the limit as x approaches a of g of x, and that is going to be L times m. So using that property, we have the limit as x approaches a of f of x times the limit as x approaches a of c. So the limit as x approaches a of f of x is L, and the limit as x approaches a of c is simply c. And so we have CL. Now we can expand upon the product property, and so the limit as x approaches a of f of x, then raised to the p, because it's the same as multiplying it out p times, is simply going to be L to the p. And the last one that we saw, we used in number 5, the limit as x approaches a of c is simply c. Okay, so let's look at this graphically. And so we have the limit as x approaches 2 from the left of f of x plus the limit as x approaches 2 from the left of g of x. So as we are approaching 2 from the left, this is going to be -5 plus, and again 2 from the left, we're going to call it about -3. So -8. Oops, and I apologize. I'm looking at it from -2, so let me go back and fix that. All right, look at this again. So the limit as x approaches +2 from the left of f of x is 3, and the limit as x approaches +2 from the right is 1, and so that limit is 4. Looking at B, we have the limit as x is approaching -1 of 2 times f of x, so that's going to be 2 times -6 minus 3 times, as we're approaching -1, is going to be -1. And so we have -12 plus 3, and that gives us -9. For C, the limit as x approaches -3 of f of x is going to be -2 minus our limit as x approaches negative 3 of g of x, and that does not exist, and so this limit does not exist. And it does not exist because the limit as x approaches negative 3 of g of x does not exist. Okay, so D, we have the limit as x approaches 6 of negative 2 times f of x, so that's going to be negative 2 times 4, and the limit as x approaches 6 of g of x is going to be positive 4, and so that limit is negative 2. The limit as x approaches 4 of f of x, so we have 2 times, the limit as x approaches 4 is negative 3, and the limit as x approaches 4 of g of x is going to be positive 4, and so we have negative 24. Okay, so looking at f, the limit as x approaches negative 2, well, we can see that it's approaching a different value from the left as it is from the right. Apologize, that's again positive 2, so let's come back to the right side. All right, the limit as x approaches negative 2 is over here. That's negative 5. So we have negative 5 squared is 25. All right, so we have the limit as x approaches 2 from the right of g of x, square root of 2 times g of x, and so we have 2 times that limit is going to be 6. So we have 2 times 6, and so that's going to be the square root of 12. The limit as x approaches 2 from the right of f of x is going to be negative 2. The limit as x approaches 2 from the right of g of x is going to be 6, and so we have negative 1/3. And lastly, we have the limit as x approaches negative 1 of f of x minus g of x. So as we approach negative 1, this is negative 6. The limit as x approaches negative 1 of g of x is going to be negative 1, and so this is negative 5.